Okay, so slide number 1. I forgot to write 2 words on here. Will you write this, please? And that is, put those 2 words down, and of course we got to do that. Write an equation of a parabola that has a vertex at 2, -3 and passes through the point what? 4, 5. Now I want you to do this 2 different ways. I want you to do it by graphing, and then I want you to do it by an algebraic approach. I think when you're done, I think I know what you're going to like. So we're going to do it both ways. Okay? So here we go. The vertex is what? 2, -3 passes through the point 4, 5. Well, 2, -3 looks to be about here. And 4, 5 looks like it's here. Okay? Now, once you get that on paper, do you know any more points on the problem? Come on, guys, say it. What is it? 0, 5. Yeah, you got to think of this axis of symmetry, right? That's your axis of symmetry, mirrored across. If 4, 5 is on there, then 0, 5 is also on there. So what does your parabola look like? It looks like this. Okay? Now, you want to write the equation to this parabola. Well, every equation can be written in standard form. And standard form is y equals, now this is a parabola, so it's going to be x squared. Well, remember your parent gets moved right or left, so that'd be what? Minus h, and then up or down, that's plus k. And there's always going to be a stretch a. Now maybe the stretch is 1, but you know, it could be 2, 3, 4, who knows? Okay, ready? I'll do this part. Y equals. There, I took the easy part. Somebody give me the inside. X minus h. X minus what? 2 squared. Because you slid your parent 2 to the right. Okay, now you're sliding your parent down 3, I think. Okay, down 3. So what's the number on the outside? Minus 3. Okay. What's the A value right here? 2. You think it's 2? Okay. Why is it 2? Because when you take your vertex and you slide over and count how high this point is, from 2 to 4 is 2 to the right. So I moved 2 to the right, and then how far up did I go? I went from -3 up to +5, so that's what? 8. Normal parent goes over 2 up what? 4. So the normal parent goes this high. You just did what to the height? You doubled the height from 4 to 8. So your A value is 2. Do you like that method? You know why that problem's easy? Do you know why? You came up with that number really easy, right? Because it was exactly double. What if it would have been 2.1 or 2.15? Could you have done that in your head? Probably not. I mean, it would not have been easy for you, okay? So this is not a great method. It's only good if the number is 2 or 3 or 4 or 1/2. Fractions get kind of difficult. What if the fraction would have been 2/5? See, the A value is tough. So there must be a better way, and the better way is probably this way. Algebraically, if we did it this way, okay, here we go. Okay, ready? You know you're sliding which way? Which way did we slide? Right 2, so that's -2. You know you slid down 3, okay. So you're almost done, guys. You're almost done. You're just missing what? You're missing A. Okay. Well, how do I get A algebraic? Aaron?
We should plug
Which point do you want me to plug in?
4, 5.
Yeah, I take the, yeah. Although this might be an easier point because it's got 0 in it, but let's just go with 4, 5. Where does the 4 go? It has to go in for x. Where does the 5 go? In for y. Go solve it for a. You better get 2 because we already did it. It's 2. All right, here we go. 5 equals a times 4 minus 2 squared minus 3. 5 equals 4 minus 2 is 2. 2 squared is 4. 4 times a is 4a. Solve for a. 4a equals what? 8. Divided by 4? 2. Hey, look at that, guys. It's the same thing, isn't it? So which way do you like better? Algebraically? Because it's... Why'd you like it better anyway?
It's quicker.
It's quicker. Okay. I was thinking that, in my mind, I think it's kind of like a for sure bet. If I'm good at solving equations, this is easy. That is not so easy over there because what if I would have been at 4, 6? That's not easy to come up with a stretch factor. You know what I'm saying? If the stretch factor is not a whole number, you're in trouble. Okay, you better have the algebraic way to do it in your head. Okay? All right, move on. Move on. Okay, here we go. The next slide says quadratic functions typically appear in 2 different ways. This way or this way. Now this one is called what form? Standard. Now you guys, when the book says put it in standard form, that's it. They want it to look like that. And why? Because we can do what in standard form? We can graph it really, really quick. Let's just say it's easy to graph in this method. Now this method is called the what method? Or sorry, what form? Now general form. And to graph out of this is, I'm just going to say more difficult. Okay, more difficult, whoops, called to graph. Okay, and there is a little secret to this one. There's a secret on how to graph this. Does anybody remember? If you get that look. Okay, watch. Okay, 3x squared plus x minus 4. Do you remember how to graph that? Nobody remembers the secret? Well, stay tuned. It's coming in 4 or 5 slides. Do you know the secret?
Would it be, would you just have to solve it? Get 2 points out of it, or simplify it?
Aaron, you're being too general there. I can't. You don't have it. Not yet. You'll get it.
Isn't C the C is just the Y?
The Y.
Intercept.
Yes, it is. C is the Y intercept. Good. But that's not the secret. It's coming. Okay. So here we go. You'll figure out the secret in about 4 or 5 slides. Graphing quadratic functions. There are 2 methods. One of them is this one. Do your transformations. But to do your transformations, guys, it has to be in standard form. Standard form is this. Okay, everything has to look like that in order for you to graph it. Okay, so we want this to look like this. How do we do it? I'll give you 3 words. Complete the square. There it is. Complete the square. Do you remember doing it last year? Fortunately, you do?
Yeah.
Unfortunately, you don't. Okay. Yeah. Here's the deal. We did it last year for a couple days, and we quizzed you, then we tested you, and we said, done. That's all we did. Okay, so you probably don't remember it, but it's going to come back quick. Okay, so let me give you, for instance, what it is. Your job is to come up with something like this. You need to get a trinomial where the first term is a perfect square and the last term is a perfect square. Do you agree these are both perfect squares? Okay, see the middle term? The middle term would have to be something like this. 6 times 6 is what? 36. But then you come over here and you go 6 plus 6. Guess what the middle term is? Has to be what? 12x. It's a trinomial. And what do we do with those kind of perfect square trinomials? We factor them. And then when you factor them, here's the look. The look is x plus 6 times x plus 6, or better yet, this. That's what you're going to get today. And if you look at that, guys, doesn't that look like this? X minus h squared. Isn't that what that looks like? And that's why you're going to do it. You're going to try to complete the square to get this look. So then you know the vertex is left or right 6. Okay? All right. Come on back, because I'll show you what to do. Now you forgot the method, so here we go. Copy f of x down. And now I got to tell you this. Every book does it different. If you read any math book, some books do it this way, some books do it this way. They're probably all right. How did your math teacher do it last year? I don't know, unless you had me. Okay. Here's how we're going to do it this year. Your book says you always want 1x squared. That's what I have. I have 1x squared. Okay. Copy it down. Then move down to minus 6x. See that last number, minus 4? Push it out like a couple inches or so. Push it over here. Create yourself a little blank. And that little blank is for you to complete the square. You need a number. You need a number like this. 6 times 6 is 36. But 6 plus 6 is going to be this number right there. This is not 36, because 6 times 6 is 36. 6 plus 6 is not 6. Any ideas what it is?
3.
Okay. You want it to be what? 9, because isn't 3 times 3 9? Isn't 3 plus 3 6? Yeah, it is 9. But hang on. How do you get it? This is the part where I was hoping you'd remember something here. Okay, so how do we get that perfect square 9?
Isn't it half of b squared?
Half of b, take half of b and then do what to it? Square what?
B.
The b or everything?
Everything.
Everything. Square everything. That is exactly how you find the perfect square. So what's your b value, guys? Negative 6. Cut it in half. Negative 3. Square negative 3. 9. That's the answer. 9. You want 9 right here. So put a plus 9. Okay. Now, your teacher last year said if you add 9 to this side, what do you do to this side? Add 9. But wait a minute. I got to tell you, your book doesn't do it that way. Because you know what your book does? Your book says if you add 9 over here, eventually you're going to push it back that way. So then you'd subtract 9. So here's what your book does. Your book says add 9, then subtract 9, because that's like doing what? That's like doing nothing. It's like I didn't change the equation. I wrote it differently, but I didn't change it. So now, what I want you to do from this point on is this. Once you put your perfect square there, let's just sorry. Let's group this. Let's group this. I messed up. Sorry, I don't want this one in there. Okay. So just group it. Now, inside the grouping, all you want is the first 9. This 9, you actually push it out on the outside. So what you do now is you just rewrite this. Okay? Okay, so what you want are those 3 terms, and then kick that 9 out, and it becomes this and this, right? Now, why is that all in there? Because that's a perfect trinomial. It factors into what? X what?
Minus 3.
X minus 3 times x minus 3. square. Negative 3 times negative 3 is 9, and negative 3 plus negative 3 is negative 6. It works. What's the number on the outside? Negative 13 equals f of x. Now, why is that so nice? Because you can do what? Graph it. You can graph it. So quick, make a quick graph of this so that I know you know what you're doing. Okay, where's vertex? Three to the right, down 13. Yep, 3, negative 13. Okay, so a quick sketch would be 3 over and 13 down. Now remember, this is just a sketch. Help me, where do I go now? What's the A value? Yeah, the A value is 1, right here. There's the A value. If it's 1, it acts just like who? Who's it acting like?
Parent.
Your parent. Over 1, up 1, over 2, up 4. Here's that axis of symmetry, right? Mirror it, and there's your look. Good? That's just a quick sketch, okay? Hey, really quick, somebody tell me the equation. What's the equation to the AOS, axis of symmetry?
X equals 3.
X equals 3. Isn't it always going to be this? Whatever the x value on your vertex is? All right, that's too much time. You take over. Do the next slide by yourself. Turn the page, or turn the slide, go to the next slide. The next slide is just like this slide. You guys, all you gotta do is look back and forth, back and forth. You should be able to get this. Hint, hint, there's your start. That's what you should have already done. Push the 9 out, get yourself a blank, fill in the blank. Anybody stuck? So what was the perfect square? What was that perfect square? You needed to put it right here. 16? Okay, let's try it. Half of B. B is 8, so half of 8. Square it. Well, that's just 4 squared, which is what? 16. Okay, Harry's right, plus 16, but you know what I'm going to do? I'm going to go minus 16, which just basically means I added what?
0.
Nothing. I didn't change the question or the equation. Okay, well, the next step would be kick out the negative 16. Kick it out. So when you kick it out, it becomes negative 16 plus 9 equals f of x. Factor it. Factor this, Everett. What is this?
X plus 4 squared.
X plus 4 times x plus 4, or square. And then minus or plus?
Minus.
Minus
7.
7. F of x equals that. Is that in standard form? Yeah. What's the a value?
1.
1. So it's going to act like what? Your parent. Okay. Quick. Sketch it. vertex. Eddie, what's the vertex here?
-4,
Negative 4, -7, he says. Good. AOS. Jeff, what's the AOS? Axis of symmetry. The vertical line that cuts it in half. I know you were gone yesterday, Jeff. Elizabeth, do you know?
-4.
Can't you say -4? It's a vertical line.
X equals -4.
X equals -4. It's always going to be what? The x value on your vertex. Okay. A quick sketch would be like this. Okay, let's see. Left 4, down 7. Down 7. Right above there. And we know the a value is +1. It goes up. Right 1. Up 1. Right 2. Up what? 4. Mirror it and mirror it. And what you're mirroring over is this line right here. There it goes. Okay? Okay. Go to the next slide, and what do you notice? We're going to do it again, by the way. We're going to complete square. What do you notice?
2.
Okay. Now the x squared is no longer a perfect square. It's got a number other than 1. So this creates a problem for you. So let's just do this. Let's start the same way. What do we do with the 5? Move it up. Okay? Okay, do this and this. Okay, that's your first thing you do. Guys, you will do this all year long, so if you don't learn how to complete the square now, you're in trouble. Okay? We want it to be x squared, so what do we do now?
Divide by 2.
I could, but then I'm going to have f of x divided by 2 because you want me to divide everything by 2. And I don't want that mess. That's just too much of a mess. But you could do that if you want.
Take 2 out of the 2x squared and the -6.
So when you say take the 2 out, you're really telling me to factor it out. There you go. Factor out the 2. Whatever the coefficient is, if it's 2, factor out 2. If it's 3, factor out of 3. If it's 1/2, factor out of 1/2. Okay? So when you do that, guys, tell me what's inside. 2 times. 2 times. X squared minus 3x. There you go. Plus blank. Good? Okay. Now you're back to where you started. How do you get that perfect square right there? Half of b, square it. What's your b? Sylvester, what's your b? What? Say again. 3. Ooh, careful.
6.
3.5 squared.
Well, it's -3. That's why I said, just be careful with the sign. -3 divide by what? 2. Do what to it? Square it. Now don't turn everything into a decimal, please. Leave it. What's -3/2 times -3/2? 9/4. There you go. Your answer should have been add 9/4, subtract 9/4. There you go. Okay. Now kick out the extra 9/4. So you're going to get 2 times this minus this plus this. But when you kick this out, guys, there's a problem. And what's the problem? You don't see a problem? When you stuck in that 9/4, you know what you did? You stuck in a 9/4, but what was out in front? A 2, so you didn't really add 9/4, you added 9/4 times 2. So that's the problem. You can't just kick out -9/4. You got to kick out 18/4. There you go. So you got to kick out an 18/4, and you already have a 5 out here. Okay? Now, The nice thing about the parentheses, this is factorable. What does it factor into? X minus what? Did you say 1/2 or 3/2?
Oh, yeah, yeah.
Okay. Your answer is always right there, by the way. If you ever want to know what that number is, it's what you squared, right? So if you say, what is the square root of this? It's this. Okay? And then these two numbers, when you add or subtract them, these are just fractions. Common denominator. What's the common denominator? 4 and 1. I'd go with a 4. Okay, take this times 4, take this times 4. It's really what? 20/4. So what is negative 18/4 and negative 20/4? It's what?
9 2/4.
Louder. You're so quiet. Louder. Negative 9 2/4. Oh, 9.5. Oh, okay. Okay. I got what you're saying now. But this is really negative 38 fours, which you guys reduce to what? 19 halves, which is 9.5. Okay, I got you. Okay, so if I look right here, guys, this is giving me everything I need. What's the vertex on this one? John, what's the vertex?
Vertex. 3 halves.
Okay.
Negative 38/4.
Negative 38/4. But you can reduce it to negative 19 halves. And some of you are calling that 9.5. And that's right, negative 9.5. Okay, so this is the vertex of your parabola. AOS. X equals 3 halves. Okay, 1.5, 3 halves. Okay, good. Could you quick sketch that? Do you know where these points are? How far to the right? One, 2, 3. So it's 1.5 to the right and down how far? Negative 9.5. Well, there's 1.5. There's negative 9.5. Okay? And then you have to think about the stretch factor. Is there a stretch factor? Right here. So it's 2. So you go what? Over 1 and up twice as high. Over 2, you'd have to go up what? Don't go up 4. Go up 8. You'd be really close to the x-axis by now. There you go. With graph paper, that's much easier, I promise. Okay? So do you feel like you can complete the square?
Yes.
Okay. All right. Remember that secret I was talking about? Here it comes. So what they did is this. They said, well, what if? What if you get it in what form? What if you get it in this form, the general form? How are you going to graph it and find the vertex? So what they did is they took this and they completed the square. I'm not going to sit here and show you how they did it, but they did it and they came up with this mess right there. Here's the answer.
Oh, yeah.
This is in what form? Standard form. Which you should know I can get the vertex out of standard form. Now, guys, looking? Are you looking? Look inside the grouping symbol where it says x plus b over 2a squared. This is telling you, move your parent where? Right or left? Okay, where am I going to go? B over 2a, he says. Move it b over 2a. Well, which way? It says plus. Left. You got to go left because it says plus. So left would be how far? It'd be negative b over 2a. This is what I was trying to get you to say. So when you guys are in that form, how do you find the vertex? How do you find the x value? Negative b over 2a. That's how you find it. Your teacher told you that last year. How did they get this? They completed the square on the general form and got that. And that's what tells you the vertex is this far to the left. Okay? Now this number right here, this y value, is actually this number right here. Well, that's way too confusing. So you know what we're going to do? To get the y value, what would you do? If you knew the x value. If I knew the x value was 2, how would I get the y value? Plug it in. Exactly. So you take that number and you plug it into your function. So they say basically this. If you know this number, you plug it into your function to get the y value. Okay. Now that might be a little too much information for you. You can't handle that. It's just too much. But really all I care about is this. Do you understand? This is how you get the what? X value of your what? Vertex. That's it. That's all I want you to understand. So if I confused you, I'm sorry. But that's all I wanted you to understand. Okay. Here we go. The next slide says, graph that function. Right here. And because it's in what form? General form, use what to find the vertex? How do you get that number? Negative b over 2a. Okay? Try to get it right now, without my help. Try to get that x value. Okay, there's your A, B, C. Opposite of B, what'd you guys put? 6, right? 2 times A? 6. So that's 6 over 6, which is? 1. There it is. Your vertex is 1 comma something. How do you?
It's 10.
It's what?
10.
4? Okay. How'd you get 4? You plug it in right here. You plug it in right here. That's what I was trying to tell you. Basically do this. If my x value is 1, what's the value of my function when x is 1? Well, you just plug it in. There you go. You should get something like that, which is what? 4. So your y value is 4. So 1 comma 4 is your vertex, your axis of symmetry. AOS is what? X equals 1. I'm just trying to put down the information they wanted. They wanted the vertex done. They want the axis of symmetry done. Then they want additional points. And this is why this method is not a good method. It's okay. But if I was to graph this, now I need more points. To get more points, you want to make a table. Do you remember where your teacher said last year, put the vertex where in the table? In the middle. Okay, so go in the middle and put your vertex right here. Okay. Now, when making a table, if that's your vertex, if you slide one to the right of your vertex then the y value should be the same as 1 to the left of your vertex. So we did this. We always said get one bigger, 2. Get one bigger, 3. This way get one smaller, 0 and 1. That's how we did it. And then we said, these two y values, they should be identical. Because they're just mirrored. They're just mirrored across. What number is the easier number to try? 0 or 2?
0.
0. Put it in. What's the answer? This one's an easy one. Put 0 in. If you're going to make me do this, it's going to slow us down. 7? Okay. 7. And this should be 7 because they're mirrored across. Okay. Now, out of these two numbers, 1 and, well, that's a negative 1. I'm sorry. Negative 1 and 3? I don't know. If you don't mind negatives, this is probably easy. Anybody get it? Okay. No one's saying it, so I'll just wait.
16.
16, okay. So there is your vertex, 16 I heard. 16. Now, here's the deal. You know 5, 6, 7's here, and you know 2 7's here. I just have a quick question for you. Are you looking at this going, wait a second, I don't think I had to make that table. Like, I should have known this point was on the problem. I should have known that point was on the problem because why? Stretch by 3. Yeah. Eddie says there's a stretch by 3. He's right. Look at this. That's your A value. Your A value is 3. You guys probably could have graphed that because all you had to do was what? Over 1. Up 1? No. Over 1 what? 3 times higher. Right there. Over 2, normally it's up 4. You're going to go 12 times higher, guys, because the stretch factor is 12. If you go 12 higher than 4, where are you going to end up? Where's you going to end up at 16? Right there. And that's what we said we were going to get. We were going to get 16. You could have done it. Probably without doing all those the table work. Okay. Will you do me a favor right now? Change these variables to h, and you can leave it as t, but underneath the t, would you put seconds, like that? I just don't like how it's worded, and I'm going to change the wording for next year, okay? Here we go. A projectile is fired into the air. Following this model, h of t equals negative 16 t squared plus 80t plus 15. Okay, when you start reading story problems, go like this. Make a quick xy table and label the x-axis. Which one's x? Is it height of the projectile or is it time? It's time, it's what you're plugging in. So this is time in seconds. And then this is h, the height. Okay, h of t. H after t seconds. All right. Now, once you do that, is there a number up here that's telling you anything, any information about your graph?
Y-intercept.
The what?
Y-intercept.
Which one's the y-intercept?
C.
C. It's always C. This is always going to be the y-intercept. So right now, guys, I should be thinking the projectile was 15 feet off the ground when it was shot up in the air. Okay? At 0 seconds. All right. Now, do I know if the parabola goes up or down? Does it point up or is it down? It's down because the A value is what? Negative. Okay, so I know when the projectile is going this way. It's going to hit the ground later. Okay, here comes the question. When? When is the question? Does that sound like height or time? That's time. When does the projectile reach the maximum height? Well, the maximum height is right here.
Delta X.
Well, how are you going to find it? It's the vertex and what? Oh, you said vertex. Okay. How are you going to find the vertex? You can't use your calculator, guys. Yeah, negative b, I'll go up here, negative b over 2a. That's going to be the x value. Do it. Anybody have it? Just curious? One person has it. All right, keep going. I'm getting negative 80 divided by negative 32, which is what?
That would do.
2.5. All right. 5 over 2, somebody said. That's the same thing. Okay, you want the y value? Put this back in here. Put this back in here. Work it out. And I know the bell's going to ring, so I need an answer quick. $115. Okay. Now remember, the first number is your x, the second one is your y. This is time, this is height. So what's the answer to when does the projectile hit the maximum height? It's this one, 2.5. You got to know what the question was. The answer is 2.5 seconds. Have you read the last question? Will the projectile ever reach a height of 120? Why not?
Because the maximum is
You already know the max. The max is 115. So the answer is what? No. That's it. That's all I got. Lots of talk, but lots of information. You have to be able to function on that assignment. Any calculators out there?
Isn't the next period English or Chinese? The whole time I was sitting there, I was like, how could I change my mind to make it there's no formulas we have for this.
Then you grab the No, then you get.
Give him the 0.
You know what I'm saying? You know, you can read on
I think we have everything we need to figure it out.
famous last words. I'll be here for sure. Jeff told me that a couple days ago, and then Jeff missed it.
No, we don't need the wind. We're imagining it's in a controlled environment. There is no wind.
Hey, Jeff's ready. Hey, no, sir. Hey, I need to see Chloe, Hunter, Sylvester, Jeff. Let's make sure you say something. You ready?
Kind
ready?
of on right now.
Are you sure you're ready? You've been gone a long time. You're ready? Yeah, you can see it. Okay, you ready?
Nice mine too.
Yep. Chloe, here's your test. I got yours. Ready? Jeff, are you positive that if you can't say I'm not ready.
Maddie, what's the game tonight? 7.
You get what I'm saying, right? Yeah. You can't start crying. There you go, buddy.
Okay.
Sylvester, you ready?
I would like to hear.
Oh, yeah. Okay. How about your book assignment? Did you ever get that done? Oh, yeah. Now I remember the deal. Sorry. Thanks for reminding me.
Oh, I have my review assignments, but I just get it out.
Just later. Just don't forget.
Okay.
Okay. This is now 51. So it's this out of 51. Well, what I'm trying to tell all three of you is I made it better for you because I didn't like a couple problems. A couple problems I didn't like, and they were basically the domain problems.
Oh my
So,
gosh, I thought you did on those.
okay, I'm gonna YouTube. There.
Okay, I'll be back after.
Okay, and Liz, Maddie.
I have a question.
Okay.
Is there always going to be a K value when you do inverse? Or like you do like the indirect?
Oh, yeah. Oh, I'm sorry. Inverse variation is always going to be k to y equals k over x. There's always going to be a k.
That's my only question.
And then direct is y equals. Okay. No, you're fine, aren't you? Look at that. How did I forget you? Have you done that? I got it. I got it on my Twitter. All right. You're leaving? Okay.
Can she take it here?
Sure.
She
She's
might,
coming
I'm
in.
not leaving till about 22.
So you're
I'll
talking
see.
3 o'clock, aren't you?
Well, I'm thinking she should be here by 2:30, but
Okay.
yeah.
Oh, so
Yeah.
you'll give it to her, she'll walk
Yeah.
down. Okay. Are you ready? You're out of here.
Well, 22.
Do you want to just give, oh, she doesn't know to come in my room.
Well, I did say if my daughter
Go to my room.
here, so I'll see what time she gets there. But I will bring her here to start probably right away.
Good.
Okay.
All right, everybody has a test, everybody's working on it. Yeah, sure. Maddie?
Yeah.
I did. I was gonna tell you guys that. Did I get three pages?
Yeah.
Yeah. Okay, so I did grade everybody's. They're done.
Jacob Daniela, please come to the main office. Jacob Daniela, please come to the main office.
So you went up 9%. So you picked up a letter grade for sure. You got what you really did though is you really did 18%. But I had to meet you in the middle, so then and I don't remember your percentage. I'd have to look it up. Was that what it was?
That's my first test.
Okay, so that's roughly 60. So you, that you, so you get 62, you got 9 years, 71. But the important thing to me is you went up. And really you went up, almost 20.
It's almost 2 grades.
Yeah. Well, then again, I hope you understand that the reason I can't do that is because if somebody got an 80 and then they get 100 on the next test. Well, yeah, what was the kid that gets 97? Well, now this person did worse than this person. Now did better. It just doesn't seem to be fair. That's just my opinion. You don't care. Okay, but you did 9% better. Okay? Yeah. You just left a couple of hours ago, right?
Yeah. If you
Grace sits in that chair right after you.
Okay,
She never said a word.
Okay.
You
I
know,
just can't remember what class we were left in.
you know what I'm talking about? Grace.
She didn't say anything. Grace must have said. She would probably say something. She said it's
But I want
big
you to-
giant bulldozer.
Yeah. And I want you, I don't think it was there.
Okay, it's probably just like.
So this is the retakes. Okay, now you know you about 10%. Okay. All right, now. Yeah, I haven't done it.
No.
Okay. So then you go here. give me just a couple seconds. I'm gonna run the math out this quick. You guys okay? I would, if I were you, for work, I would do what's easy. Do what's easy for you. Skip. You know, come back to the hard ones last. Okay, you have a. Here, take some.